This is a digital clock made from Nixie tubes, specifically Burroughs B-5440 and 5441. This digital clock is GPS slaved. That means that it will set itself to GPS time momentarily. The second colon neon lamp that's blinking right now, along with the green one that's on the left, indicates GPS status. As you can see, it just set itself to GPS time. It'll also take a couple minutes because it's about 15 seconds behind actual time, and it'll take about 5 or so minutes to correct itself, and that's because of the GPS receiver did not get a proper fix yet. The design of this Nixie clock was done by a ham operator and engineer by the name of Michael Gray, who unfortunately passed away in 2009. But his website was extremely well documented and allowed me to completely build this project. The software was open source, and I built it with the compiler and programmed it in the microcontroller. The green neon lamp on the left indicates microcontroller status. Judging from the source code, it's hard to tell exactly what it means, but blinking on and off every second seems to be a normal status. And the design is actually very cool. If you look here, you will see what you will see two PLCC packages, and they are the high voltage drivers. Well, actually high voltage shift registers. And the shift register outputs tie the Nixie cathodes to ground, and we'll turn them on. It was a lot of wiring to do, as you can see. There's even more underneath. Towards the upper left here we have what looks like some TO92 packages, and those are transistors which do voltage level conversion from the low power 3.3 volt microcontroller to the higher voltage 12 volts 12 volt logic required by the shift registers. The pin header is the programming pin header. As you can see, we have a button here, which doesn't seem to really do anything in the source code, but it was in the hardware. This is a buck converter. Converts the input, which is around 12 volts, to 3.3 for use with the microcontroller. That's the microcontroller crystal, running around 4 megahertz, and the microcontroller is a low voltage PIC 4525. The Nixie tubes are driven with a boost converter right here. And the GPS module is a Trimble Resolution T GPS module. It's a timing receiver. It's made for purposes of timing only, and not necessarily for position fixes. It normally operates with the antenna in a stationary position and does position fixes accordingly. it operates with 3.3 volts as well as the antenna. And this module, since it's from Trimble, uses Trimble's protocol. And that's how the microcontroller talks to it, which I thought was actually pretty clever, because everybody else uses will use the standard NMEA, but in this case Michael chose to use the Trimble protocol instead, and this allowed for more accurate timing. The microcontroller connects to it with a standard serial port, as well as it utilizes the 1 pulse per second output from the receiver, and this allows for extremely accurate time. This receiver itself is rated for within, I believe, 12 or 16 nanoseconds of actual GPS time. So it's a very high performance receiver made by Trimble. And that's one of the things that I really liked about this design, was to use a timing receiver specifically for purposes of very accurate timing. The soldering took a lot, but as you can see, it was well worth it in the end. And thanks to Michael Gray for documenting this so well with basic knowledge that I have. I could easily build it. And so can you. And one thing I like about these Nixie tubes from Burroughs is specifically the fact that they have a very fine mesh, which allows for higher visibility of the digits. And once again, thank you to Michael Gray for this awesome design.